Hi everyone, we are looking at section 3.8 on implicit differentiation and specifically on question 316, which we are given this equation, which is well known as the volume of Descartes. And this is an implicit equation because we are given it in terms of both x and y, where y is a function of x. Remember, y is not the variable. Here the variable is x, but y is a function of x. And we are asked to find the equation of the tangent line at the point 2, 1. So let's see how can we do that. Remember that to find the equation of a tangent line, we need to have two things. We need to have the slope of the tangent line at x equal 2 and also a point on that tangent line. Well, they already give us that the point 2, 1 is on the tangent line. So the only thing we need to find is the slope at x equal 2. That means that we have to find out what is dx of y at x equal to 2. Well, let's start with the equation that they provide us. 2x cubed plus 2y cubed minus 9xy equals 0. I would like to differentiating both sides of this equation. And I like to use this ddx notation because it reminds me of what is the variable that I'm differentiating with respect to. In this case, we are differentiating everything with respect to x because x is the variable in this case. So what is the differentiation of 0? The derivative of 0 is just 0. On the left hand side, we have the derivative of the summation of several things. So that will be the sum of the individual derivative. And I can also apply the constant multiple rule to pull out the constant. So I will have 2 times ddx of x cubed plus 2 times ddx of y cubed minus 9 times ddx of x times y. Well, the derivative of x cubed is just 3x squared. There's nothing special about that. So we got that this is 2 times 3x squared. Over here, we have the derivative of y cubed with respect to x. Remember, here y is a function of x, so we have to apply the chain rule. So this derivative will be equal to 3y squared. I apply the power rule on the function y cubed, but then I will also have to multiply that by the derivative of the inside function, which is y, and the derivative of that will be just ddx of y. Well, we can also written this at y prime to save some space. So then this will be equal to 2 times the quantity 3y squared times y prime minus 9 multiplied by, now I have the derivative of x times y. So let's do it out here. I'm taking the derivative ddx of x times y. Here I have a product of two things, so I have to apply the product rule. So that will be the derivative of x multiplied by y plus x multiplied by the derivative of y. The derivative of x is 1 multiplied by y plus x. And here again, I can rewrite ddx of y as y prime. So it will give me that this is equal to y plus x times y prime. Let's plug that back into the original equation. So this is the same as y plus x times y prime, and this whole thing equal to 0. Let's clean this up a little bit. Okay. Alright, so now we have to simplify this a little bit. So this will give us 6x squared plus 6y squared y prime minus 9y minus 9x y prime equal to 0. Here I will have to solve this equation. I will have to solve for y prime because I'm interested in the derivative of the function. Alright, so I will keep everything that have to do with y prime on the left hand side of the equation. So that would be this term and that term, and everything else that doesn't have the y prime, I will pull it out into the other side of the equation. So I get that this is the same as 6y squared y prime minus 9x y prime. These are the two terms that have y prime, equal to negative 6x squared plus 9y. So basically I subtract 6x squared and I add 9y to the other side of the equation. Alright, here I see that I have y prime as a common factor in the two terms, so I can factor it out to get that y prime multiplied by 6y squared minus 9x is equal to negative 6x squared plus 9y. And to isolating y prime, I have to divide both sides of the equation by this factor of 6y squared minus 9x. So I will get that y prime is equal to negative 6x squared plus 9y divided by 6y squared minus 9x. And I have obtained the formula for the derivative of this function in terms of both x and y. Okay. So now I can find out what is y prime at the point 2, 1. So we know that x is equal to 2 and y is equal to 1. So I can plug x equal 2 and y equal 1 into this formula of the derivative to get the derivative at the point 2, 1. So what would I get? I get that y prime at 2 is equal to minus 6 times 2 squared plus 9 times 1 divided by 6 times 1 squared minus 9 times 2, and this is equal to negative 6 times 4 plus 9 divided by 6 minus 18, and this is equal to negative 24 plus 9 divided by 6 minus 18, and this is equal to 5/4. So the slope of the tangent line equal to 5/4, and the tangent line passed through the point 2, 1. So then we can use the point slope formula to whip up the equation of the tangent line. So the equation of the tangent line at 2, 1 is y minus y1, which is 1, equal to the slope of x minus x1, which is 2, So this gives us the equation of the tangent line. In part B of this question, we are asked to find the equation of the normal line to the tangent line at the point 2, 1. Well, the normal line is a line that's perpendicular to the tangent line. So if I have this is the tangent line, then this would be the normal line, where it makes the intersection between the two lines make a 90-degree angle. Well, because the normal line is perpendicular to the tangent line, we know that the slope of the normal line is equal to the negative of the inverse of the slope of the tangent line. So that would be negative 4 over 5, because the slope of the tangent line is 5 over 4. We also know that this normal line passed through the point 2, 1. So we can write the equation of the normal line to be y minus y1, which is 1, equal negative 4 over 5 times x minus x1, which is 2. And this is the equation of the normal line to the tangent line at this point. Let's go into Desmo and to see the graph of the equation. So here I have the function of the volume of Descartes, and we are looking at the point 2, 1. And the equation of the tangent line that we obtain is y minus 1 equal to 5 over 4 of x minus 2. And we see that this is the tangent line to the point 2, 1 on this graph. How about the normal line? That would be y minus 1 is equal to negative 4 over 5 of x minus 2. And we see clearly this normal line is perpendicular to the tangent line at the point 2, 1. Thank you.